Everyone. Today we are going to see how to develop a C program to find the roots of a quadratic equation. I have included the stdio.h because I will be making use of some input-output statements like printf and scanf. Inside the main, I will be declaring the required variables. Since the quadratic equation I am considering is ax square plus bx plus c equal to 0. Ax square plus bx plus c equal to 0. This is my equation. So I need to read the coefficients. So to store these coefficients, I will be declaring a, b, c. And to store the roots, I will be declaring root 1, root 2. And to store the discriminant, I will be using disc as a variable. Now I will be entering a message printf. Enter the coefficients. Now I have to scan these required variables, coefficients ABC. So ampersand A, ampersand B, ampersand C. You want to check whether it is a quadratic equation or not, then you have to check the coefficient A. So that we can modify it, we can check this condition later. So first we'll find the discriminant. Discriminant is equal to b square. B square is nothing but b into b, b square minus 4ac. So 4 into a into c. So this is the equivalent expression in C for b square minus 4ac. The many of you people will be forgetting to use the star between the variables. So now we will print the discriminant. Now based on the discriminant, I have to decide whether the roots are real and equal, real and unequal, or imaginary. So I will have a testing condition. If discriminant is greater than 0, then I will first print the roots are real and unequal. And I will find out what is root 1. Root 1 is equal to minus b plus square root of sqrt of discriminant minus b plus square root of discriminant divided by 2 into a. So here this is the expression for minus b plus square root of discriminant divided by 2a. So the people will forget to put a bracket at the denominator as well as this bracket which is at the numerator, so that you should never forget. Next is since you are using sqrt function, you have to include #include math.h. Next, similarly, the root 2 will be minus b minus sqrt of b square minus 4ac divided by 2a. Then printf root 1 is equal to percentage f root 2 is equal to percentage f backslash n comma root 1 comma root 2. So this is regarding the first case where the discriminant is greater than 0. Else you check whether discriminant is equal to 0. If so, printf roots are real and equal. And root 1 equal to root 2 equal to minus b divided by 2 into a. And you have to print the roots. As well as root 2, both are same. Anyone you can pass as the argument. So this is the second case where the discriminant is equal to 0. Else printf roots are imaginary. The real part of the imaginary root I will be storing in root 1. Root 1 equals to minus b divided by 2 into a, and imaginary part root 2 will be equal to, this is root 1, root 2 equals to square root of minus discriminant divided by 2 into a, and printf root 1 equals to real part, that is percentage f, real part, and I want to print it in a plus bi form, so real part plus or minus the imaginary part. So root 1 is equal to real root 1 plus percentage f I backslash n comma root 1 comma root 2. In this case, root 1 and root 2 holds the real part and the imaginary part. Don't get confused. Otherwise, you can take the different variables and store them. So the second one is minus this one. So this is without testing for the linearity. So let us run it. Okay, percentage f, because they are floating point data. Okay, no errors. So coefficients I have to enter. So let us enter 1, 4 and 3. So the discriminant is b square minus 4ac, which is 4, and the roots are real and unequal, and root 1 is minus 4 minus 1 and root 2 is minus 3. Let us check with the second case. 1, 2, 1. So here discriminant is 0, so it is the second case. So the roots are real and equal, and root 1 and root 2 are equal to minus 1. Let us check the third case. 2, 4, 6. So here the roots are, the discriminant is negative, so roots are imaginary. Root 1 is equal to minus 1 plus 1.4142 1 for I and root 2. Okay, this is a message you have to change here. Root 2 is equal to minus 1 minus. So this is proper. Now if you want to save it as quadratic equation solution. This is without testing the linearity. So if you want to check whether the equation is quadratic or not, then you can check if a equal to 0 or j is equal to 0, then you can printf not a quadratic equation. And you can terminate the program by calling exit function. So when you are inserting exit function, you make sure that you will be including the corresponding header file. #include stdlib.h. Else, if a not equal to 0 and c equal to 0 and c not equal to 0, then is here or c equal to 0. Here c not equal to 0, but a is 0, then again printf what is the difference between here is here not a quadratic equation, but you have a linear solution. Here first case not a quadratic equation and no solution. You have a solution in the second case, whereas in the first case you will not have a solution. So root 1 equals to, so here c not equal to 0 but a equals to 0, then x will be minus c by b. Here I will be printing linear equation solution is percentage f one. So this I will be exit 0. The first case is ampersand it is, and both are 0. When a is 0 as well as c is 0, it's not a quadratic equation. 0, 6, 0. So not a quadratic equation, no solution. And the second case, when a is 0, b and c are not 0. So 3, 6. Not a quadratic equation. Linear equation solution is -2. So this is regarding your roots of quadratic equation.